Hey, have you ever seen these things in your life? This one or these things or just simply this? Have you ever seen? Well, I'm pretty sure that you have, but what are these things? I think you know it as quantum computers, but are these really the quantum computers? Absolutely not. The quantum computer is basically this one, this chip. Just as regular chips, this is the chip that is actually called the quantum computer. So, what are these things? These are the fins, these are the equipments, these are the instruments that keep that chip cool. Because quantum computing produces a lot of it, and the chip needs to be cooled, and that's why we use those gold fins. Okay, so uh, quantum computer is more of a contemporary topic, and recently we heard this a lot. Okay, so what actually is a quantum computer? First, the quantum computer. If we want to understand quantum computer, we need to first understand how our modern computer, what you are using right now to watch this video, how that works actually. Well, modern computer works like this. Suppose this is your computer. This is a man, and it needs to this man needs to solve a problem, and that problem is here. He needs to unlock this chest. He has some treasure here, and he needs to unlock this chest to acquire that treasure. Okay, so this is the problem for him, and you are giving your computer some problems, and your computer is gonna unlock this chest to solve the problem and to give the solution to you. Okay, so this is the thing. Now, suppose uh, here are 100 rooms, 100 possibilities, and this man has to unlock this chest, but he needs a key, and that key can be in any room of these blocks. There are 100 of blocks. Okay, you can see the key is in this block. Okay, so the man has to go to each block, each room, and he he has to check whether the key is there or not, and then he has to go to the next room and the next room and the next room to check. When he will finish to check every room, and he will eventually find the key, and then he will solve the problem for you. And this is your computer, remember. Okay, so first thing the man has to do to go to this room, he will check if this room is containing the key or not. If this room doesn't contain the key, it's a 0. And if this room contains, it's on 1. So what 0 and 1 basically means? 0 means false and 1 means true. And your computer works with only these two numbers. Okay, these are called the bits. And it's a binary language, by the way. Computer only understands 0 and 1. No matter what you are saying to your computer, no matter what you're giving as inputs, the computer understands only 0 or 1, whether it's false or it's true. So if here is the key, it will say it's true. If here is not, it will say it's false. Okay, so the person will has to check for each block if that is true or that's false, and when he he goes there, he will find that this is true, and he will then take the key and solve the problem for you. That's how modern computer works. And suppose here are 100 of blocks. Okay, and each block, just collect, each block will take 1 second of your time, to 1 second of this man's time, to check if it's true or false. So 100 blocks will take 100 seconds of time. If there is thousands, it will take 1,000 seconds of time. If there is more, it will take more of his time. So this computer will eventually become slower and slower and slower if there is more number of blocks or rooms for this person to unlock. Okay, that's how modern computer works. So sometimes if the problem is too complex, this computer this man can take up to years to solve that problem. And there how modern computers solves this problem for us. Uh, Suppose this man, he is now Superman. Okay, he has some superpower. Have you ever played Call of Duty or PUBG? Call of Duty Mobile, especially. It has some superpower to give you when you choose to play as holographic character. When you have enemies around you, and suddenly you press the holographic button, and it suddenly clones you. It suddenly makes some holograms for you, and that's not actually you. It's your clone. So when the enemy shoots those holograms, he's not actually shooting you. He is shooting those holograms, and you are not getting damage. Okay, and that's how quantum computers work. Suppose this man has some superpower like that. It can replicate itself. Okay, this computer, this man can replicate itself. Okay, so he can be at the same time, he can be every block, he can be in every block. Okay, he has the ability to go to every block, and he has the ability to stay in every block at the same time. Suppose, just as that hologram of your game. So what will happen? Just imagine what will happen. He will eventually go into each of the block at the same time. So if there are 100 blocks, it will take only 1 second to be there. But is he actually there? He is not. But isn't he actually there? He is. So he can take two sides at the same time. Either he is there or he is not there. But he can do it at the same time. Okay? So he can stay in all the boxes at the same time. So you cannot certainly say he is here. You cannot certainly say he is not here. He's taking both sides. He's here and he's not here at the same time. Okay, that's how quantum computer works. Remember the bits? Computer can take one bit at a time, and one bit means either it's false or it's true. Okay? Now, here quantum computer works through qubits. And this is the qubit. If you can see it properly, it's 1 and 0 at the same time. Okay, it can take 1 and 0 at the same time, the same value together. Okay, so this man, suppose he is everywhere and he is also nowhere. So what will happen? In 1 second, he will be everywhere, every block of this problem, and he will find the key, and he will eliminate all the other blocks just within 1 second of his time. So here, if for 100 blocks, this man could take up to 100 seconds, but this man will only take 1 second because he's everywhere at the same time, at the same moment. He's in each of the block to check whether it's true or not. So when he finds for this block that it's true, he will take the key and he will eventually go here to unlock this problem, and then you will have your solution because this man is our computer. Okay, so that is how quantum computer actually works. And whether this computer, where it was taking 100 of your seconds or sometimes years or months, it can only solve the problem in 1 second because in that second he's everywhere. And that's how quantum computing works. And this process takes uh, I mean, a lot of cooling because it actually heats up pretty quickly. So for that reason, it actually has to be at minus 273 degrees Celsius, which is near to absolute zero. Okay, and for that reason, those cooling fins or whatever the instrument is that is used, and that's the case. And for nerds, I'm gonna go deeper. I'm gonna dive deeper. So how this qubits, how this thing is actually achieved. Have you ever heard of Niels Bohr? Niels Bohr is actually called the father of quantum computing, or no, not quantum computing. Sorry for that mistake. He is called the father of nuclear physics. Okay, so what Niels Bohr told us, what Niels Bohr's atomic model was. Do you remember this? If this is an atom, this is an atom. So this is a nucleus itself, and it's a photon. You can also call it an electron, and these are the orbitals where the electron resides. Okay, so when you are energizing this photon, when you are giving it some sort of energy, what actually happens? It absorbs that energy and it leaps out, and it goes to another orbital, the outer orbital actually. But can you see it going? Can you see it going from here to following this line and then eventually going there? Can you see it? You definitely cannot. Why? Because this thing is it's a discrete process. It's a discrete process. It's not continuous at all. You cannot just simply see this electron running towards that orbital. Okay. What happens? This electron suddenly disappears from here. Boom. It completely vanishes like a magician. Okay. It vanishes. And then it disappears and suddenly it appears here. It appears here in this orbital. Have you ever seen swans or goose or any kind of duck simply swimming in the pond, and suddenly a thread comes to him, comes to the duck, and he just dives into the water and suddenly appears to another place? Have you ever seen that? If you haven't, just go look for it. Okay, you will understand what happens. This electron simply disappears from here and appears here. So where does it go? It goes somewhere in between these two orbitals, and that is what called the quantum realm. Okay, that is called the quantum realm, where the electron goes and suddenly appears. So at that time, when it is nowhere, when it is in this quantum realm, it can be called these orbitals, both of these orbitals and these orbitals. This orbital also has some right on that electron. This orbital also has some right on that electron. So it is for both. Okay. And we're talking about the in-between line. Okay. Here, the quantum realm, where we cannot see the electron, where we haven't discovered the electron. And this is where the quantum realm is. This is where everybody is looking for. That's that electron. And here he can actually achieve that quantum state, and this is where quantum computing actually happens. Okay, we are looking for in between those two lines where the electron simply disappears, and that's the qubit. That's where it can take both values, it can take both orbitals, and it can take whatever necessary it feels. And we are looking for that in between thing. We are not simply looking for one thing and then another thing. We are simply looking for the gap. We are looking for silence between two sounds. We are looking for the pause between two breaths. And that's how quantum computing takes that qubit, and that's how the computer can solve each problem within seconds, and that's how it can actually work way beyond our imagination. It can solve problems of years within seconds. Even supercomputers of ours today is not comparable to that quantum computer at all. So I hope you have understood the concept of quantum computing pretty well after this video. Thanks for watching.